Well, hey there, everybody. Hey, hey, hey. Welcome to Astronomy Daily Live. You can call me Cosmic, and it is the 22nd of September, 2018, and it is almost exactly 24 hours before the equinox. And as I recall, we can look here really, really quick. As I recall, I'm just going to look. Um, the equinox is taking place tomorrow. Let me just remind myself here. Equinox. Whoop, got to spell it right. Equinox 20. Bad typing day. Let's see here. Equinox. There it is. Ah, yes. Okay. So, yeah. So, the equinox is going to take place at 1:54 UTC on the 23rd of September. So, 6 minutes before I start this live stream, equinox. So tomorrow's episode is definitely going to be dedicated to that. Yeah, we can sort of talk about the equinox since it'll be officially fall in the northern hemisphere and spring in the southern hemisphere. I'm going to open up my chat, see what's going on over there. Atta, hey there. Tom, nice to see you again in the chat. So Atta, yeah, I'm really glad that you are having a good time with the telescope and the community and everything. Sounds like you've got it all worked out really well. And what I've learned, right, in my few years on this planet is oh man, I started to think about something else and it just went. Anyway, the equinox is a great time of year, and I look forward to them. I'm really glad that there are two every single year because I like them so much, and having two every year is like, extremely awesome. Very awesome. We have and I think well, you know what? I'm going to save that story for tomorrow, the equinox. But let me see, because the next time we interact in this way, the equinox will have passed. It would have happened 6 minutes before that. So this is my first opportunity to wish everyone a fantastic and stupendous equinox, because the next time that we see each other on this live stream, the equinox will have, it's already gone into the past. Yeah, by 6 whole minutes. So very cool. Have a great fall, or a great spring, whichever side of the planet you are on in terms of north and south. So I've got the HOH tonight, the hydrogen hydroxide. I've got the coffee, and in the panel is Bobby. Hey there, Bobby. What is going on?
Hey, nothing much.
All is well here as well. Yeah, not much going on. Sort of took a short work day, so I've been home not all afternoon, but well, knocked a couple hours off early. So yeah, been home for a little while, just sort of messing around with things, not really anything in particular, working on my photometry, or my scope back here, still working on that. I've actually I figured out uh, my little problems in terms of how I was making the measurements of the photometry, and now I'm getting results that are believable, right?
And you want to know what's awkward? Is Jules didn't do his string today.
Oh, he didn't. He didn't, did he?
No, he didn't. I was like, what? I was like, what's the deal?
Huh. Huh. I wonder. Hope everything is okay there.
I sure hope so, unless his phone got stolen and stuff.
Hmm. Yeah. Well, I mean, he if anything happened, right, where he would sort of know that he wasn't going to be able to do it, he would let us know one way or another, right? So
And he didn't.
yeah, and he didn't, and he didn't. So I'm sort of wondering. It's like, huh? Yeah. Hmm. Well, hopefully he's okay. Just got distracted or held up, or something somewhere, and couldn't do anything about it. So lots of possibilities there. Lots of possibilities. Um, the most likely uh, thing that happened is probably the most boring one too, right? So.
Now, I usually keep it more positive and like more of a ready to go person and stuff.
Yeah. All right, well, cool. So yeah, tomorrow is definitely a special day. So yeah, let's do the equinox thing tomorrow. We can talk about, as I said, what it is, and I've got at least one equinox story that I think I've talked about a couple of times, but I can do that again. Um, yeah, yeah, we can get into that whole thing. But yeah, you know, it's one of these things that I call a shared experience, and those to me are sort of the most powerful, the most um, uh, interesting and inspiring. Are these shared experiences, and equinoxes and the solstices happen whether you know it or not, right? They just happen. And I actually think that it's kind of neat that this happens to everyone at precisely the same time, right? Exactly the same moment in time, regardless of where you are on the planet, this event occurs, right? So sometimes, right, um, the well, yeah, I need to save this for tomorrow. But one of the cool things that I should just mention, right, is that for me here locally, right, where I am in southeastern um, um, Arizona in the United States, for me here locally, the sun is setting. The sun is setting something like 20 minutes beforehand. So when I look at the sun at sunset tomorrow, right, I will be seeing it at a declination in the sky of 0 degrees, right, more or less. I mean, 20 minutes, uh, uh, 20 minutes before the equinox, yeah, it's going to be exactly at a declination of 0, and it's going to be heading south, right? The position of the sun every day is getting more and more and more south until the solstice on December 21st, 22nd, when the sun will be the most south. It'll be the entire year. But of course, that's the solstice, and that's a different thing. But that's also a shared experience, whether you know it or not. So yeah, I like those shared experiences.
Now I have a question for you. Does everybody need daylight savings time or what?
I think that we can, as long as we all agree and we all understand, then it doesn't really matter. It doesn't really matter, you know, what, whether you use standard time, daylight savings time, universal time. It doesn't really matter as long as there's an understanding there, right? And where I like to come from in terms of time is that there is only right now, right? That's the only time there is. That thing on the clock, that's more like a ruler, right? That's a measurement of time. That isn't time itself, right? So that's just a measurement of time. You're looking at temporal differences, right? So it's sort of like the same argument I make with the metric system and the English system, right? Pounds, inches, yards, versus centimeters, kilograms, kilometers. I think as long as everybody has an understanding and kind of can agree as to what units they use, then it doesn't particularly matter. I don't really care, because as far as I'm concerned, there's only now. So yeah, cheers to now. Pretty good coffee there, getting a little cooler. So yeah, come on in, friends, and let's keep looking at Pegasus. What I wanted to do was grab my Burnham's Celestial Handbook and sort of page through that. Now Burnham's is dated, right? It's a little dated. It is definitely not complete, and as I said, dated information. There is new stuff around it, but Burnham's is still a, as far as I'm concerned at least, a very excellent jumping off point, right? So it's a great place to start. You can still get these books. It's a collection of three books, and they're organized by constellation in alphabetical order. And so, there's volume 1, volume 2, volume 3. I think that Pegasus is probably in volume 3. I've got them right down here, so I'm going to reach down and see if I can find volume 3
and or Uncle Bill Duran and Andy Colley.
Hey there, Uncle Bill and Andy. Nice to see you in the chat. I'll be right back.
Should jump scare.
Okay. So, volume 3 is the one that has shown the most wear, and it's, look, we're friends here, we're adults here, so chill, right? I'm going to show you, gross and embarrassing things from time to time, but yeah, something has spilled on this. Probably coffee. Probably. But this has no front cover, and there's a front page that's supposed to be in front of this one. So it's missing the cover and the first page. It has no back or spine thing. It's just glued, right? Just glued. and then the back is also missing. Right? I've got one that still has everything. Right? It's got the front cover. It's got the first page here. Look, first page. Right? First page, and then that. Right? You can sort of see in there. It's got the spine, although it's coming up here, and it's got the back. But the problem is that now the front has come off. So yeah, it's I guess I still need to tape that on there. But anyway, look for these in used bookstores, right? I usually I would say more than half the time I see at least one of these, if not all three. So this, as I said, these are a little bit dated, but it's a excellent jumping off point.
If it's old but not worn, it must not have been useful, right?
These, look, I've had this set for I want to say 37 years. I've had this set. So the fact that that all the pages are still here, right? And I mean, it's in good condition except for the covers, right? No problem, right? There you go. So
you can say it's in fair condition or something like that.
yeah, I mean, nobody would want to buy these, right? Because I mean, look at that, right? I mean, who wants that, right? So these are mine. You got to find your own. Anyway, so Pegasus turns out to be the first constellation. No, I take that back. Pavo, the constellation Pavo is the first constellation in this book. Pegasus is the second. It's the second. So I'm just going to show you. So what Burnham's does is it lists. It gives a big list of all of the known multiple star systems, usually binaries, but sometimes there's 3 or 4, whatever. Then it gives a list of all the known variable stars. And then it gives a list of all the known non-stellar objects, right? So galaxies, globular clusters, open clusters, nebulae, those kinds of things, right? A big list of those. And then what it does, after these lists, well, here, I'll show you the list first. Okay, so here are the binary stars at the time known in Pegasus. Okay, here's page 1 and 2. And here's page 3 and 4. And page 5 and 6. And maybe 6.5. About 6.5. So then here's all the variable stars starting here and going over to this page. And here's the rest of the variable stars. And then here's the start of the non-stellar. And you can sort of see there's the galaxy, globular cluster, galaxy. These are all, are all galaxies. And then here's a couple more galaxies there, right? So, yeah, just sort of basic information, right? The NGC number, New General Catalog number, any other designation, right? The type, there's a open cluster in there. It says a group of 7 small stars, magnitudes 11 to 14, diameter 1.6 arc minutes. And there's an asterisk next to it. And when there's an asterisk, next to it, that means that this object is going to be mentioned in the text. Now, the text is sort of the next part, and what it does is it goes through many of the bright stars, and it gives a very long, or can be very, very long and detailed description of the star, right? Sort of its history, how it was named, any observations, anything at all. So Alpha Pegasi, right, has all of this info. There's some coins there. I don't know what that is. And then here's just a little bit more up here. And then it goes on to Beta Pegasi. And it talks about that a little bit. And it does Gamma and Epsilon and Zeta and Eta and Kappa. So it's very, very cool, right? So Kappa Pegasi is a binary star. Trying to see here. It's a parallactic, at least according to this, a parallactic distance is close to 100 light years. So the primary star is magnitude 4.27, and the companion star is about 11th magnitude. So William Herschel first saw this binary star back in 1776. So yeah, it's just some great information. Here's the orbit of Kappa Pegasi with the dates on there. Look, there's no date on this one. What's that one? Who knows? So then, after sort of the bright stars, any kind of notable stars with some kind of history or a name, or in this case, right, I mean, it's a binary star, then they'll go through some of the variable stars too. And so they're highlighting here Mu 37 Pegasi. 37 is another. I guess these are all binaries too. Yeah, I guess these are all binaries also. Here's 37 Peg. Got the orbit of this guy is almost in line with our orbit, so it looks like it's just sort of on its side there. And here's another one down here. So pretty cool. Binary stars, 85 Pegasi, apparent orbit. Looks like it's zipping around pretty fast. Pretty fast. A period of 26.27 years. Cool. Yeah, so here's some variable stars. U Pegasi. Here's a light curve of U Pegasi. So that's pretty cool. You can see the number of hours at the bottom: 1, 2, 3, 4, 5, 6, 7, 8 hours. So kind of an interesting light curve. Kind of interesting. Just sort of scanning these really quick. It's these are the kinds of books that I really like, that are just like information dense, right? Just packed full. I mean, and you have to sort of rip it apart, to even like see between things, because it's just so dense, so full of info. And yeah, it just goes on and on and on here. Okay, so there's M15, which we looked at yesterday, that great globular cluster up there. And for sure, in the city, I don't know if you can see it in the city. Might be washed out in the city, but if you get out a little bit where it's a little bit dark, then you should be able to see it with binoculars, and definitely with a telescope. So that is a must. That is a must. So let's see. Yeah, that neutron star being seen in the infrared. That's an interesting one. Yeah, I grabbed the paper. I sort of skimmed it a little bit. Haven't really gotten deep into it yet, but yeah, kind of an interesting thing going on there. I looked at, I sort of glanced at their conclusions, and I don't know. They're talking about a supernova going off, and then that's not all of it, but some of it sort of collapsing back in, and I don't know. That's a tough one.
I almost lost you in a bit.
You almost lost me?
Yeah. Now you're starting to be like either pixelated or out of focus or anything.
I don't know. Let me, I think I am a little bit out of focus, so I'm going to show you my big ugly hand. Let it focus on that. Come on. Come on, you can do it. It doesn't want to focus. Come on. Wow. Okay. I don't know if that's any better or not. Anyway, so definitely take a look at M15 with your telescope.
I just had to ban somebody too.
Oh yeah? Who's that? I want to see. Jake? I want to see what Jake said. All right, Jake. Thanks for coming in. Bam. Bam. Smash. Yeah. Thank you, Bobby, for the smash. That's cool. That's
crash, cool. Thrash, and bash.
Bam. It's just incredible power you have with that wrench. Wham. All right. Cheers. Cheers to the Blue Crew.
The ones with either with a sledgehammer or the ones with a gun.
Bam. Use that wrench. All right, cool. So yeah, M15 for sure. Take a look. It's something you definitely want to see, because it's fabulous. Now talking
about wrenches and stuff. Have you ever heard Foster the People before?
Heard of what?
Foster the People.
Foster the People?
Yeah.
No. What is that?
One of good. It's an alternative rock band, but one of the songs that I really like the most, that really is more like me, is called "Pumped Up Kicks." You should take a look at that.
All right. You why don't you over on the Discord server on the art channel? Why don't you post a link to a song or sample of songs, and I will of course take a listen. Of course.
I just gotta open up my Discord first.
Cool.
I haven't had my Discord up and down for quite some time.
Yeah. Anyway, so Burnham's really doesn't do M15 justice. That's a pretty sad shot of M15. When you look at it through a telescope, you'll be blown away. You'll be totally blown away. It's a fantastic globular. M13 gets all the oohs and ahs, but M13 is okay. But I like M5. I like M15. I like M22. M22 is fabulous, right? And it's huge. It's huge. And I can say though, I got to say that probably the most amazing globular in the sky, in my opinion, is Omega Centauri. And that is an object that us northerners really can't see really well. I can see it when it's up, right? It's I think the highest it gets here is maybe 10 or 15 degrees. Yeah, I can't be exactly sure. Not very high, but it can be seen. And oh my gosh, it is like, yeah, it's absolutely amazing. Absolutely amazing. Hey there, Totterbert. Nice to see you in the chat. Thanks for coming in.
Did you get Atalana's comment?
Yeah, and M15 is up in the late evening. It's rising when the sun sets. So it's got to come up a couple hours, right? So I mean, it's high enough up, maybe 2 hours after sunset. So yeah, definitely take a look at M15. There's also a fabulous galaxy that, if you're in a dark site, it's really worth taking a look, and that's NGC 7331. It's a fantastic spiral galaxy that's sort of almost edge on, right? So that's sort of edge on. Here, let me get my hand. See, that's edge on. This galaxy is tilted, right, about like that. So if it was face on, it'd be a spiral, right? Pretty round, right? I know my hand isn't round. Here we go. Yeah, so pretty round, but in this case, we're sort of viewing it like, well, either like that or like that, right? Doesn't really matter which way, and it's too hard to tell, right? But it's sort of angled like that. It's still round, right? It's just that our point of view makes it look like that, right? And so all the spiral arms are inside of here, that, right? So that's what we're seeing. That's what we're seeing there. Same kind of thing, and you can see the spiral arms, and you can see the dark lanes and all that. And with the telescope, even with an 8-inch, you can actually get a hint of that dark lane, and that is very cool. It's always nice to see sort of details with your own eyeballs, right? It's a nice connection to have with that object. So cheers. Todderbert, you are doing a giveaway. Very, very cool. Very cool. I will have to check that out for sure. I'm not really into contests or anything. I you know I I really enjoy uh, sort of observing the process and watching the winner and just how absolutely overjoyed they are. That that gives me actually more joy than uh, actually winning some kind of contest. I I like the reaction of the contest winner. I think it's great most of the time. Yeah, most of the time. But yeah, I will definitely check that out, and everybody else too. Todderbert, he reviews um, sort of not necessarily vintage radios, but all kinds of different brands of radios, um, different kinds of radios, different bands, and just I had absolutely no idea that there were that many makes and models of little radios. So yeah, and Todderbert does a really great job to make it um, um, really interesting. It's not just a yeah. I mean, it's not the kind of thing where it's like, well, he's talking a lot, but he's not saying much, right? No, this is really interesting info, and the presentation is great, and yeah, so check him out. Check him out. He's great. And you got your technician's class license. Well, congratulations. That's very, very cool. Yeah, at some point, probably at some point, I will get my ham license as well. Um, maybe. It's just a matter of doing it. So yeah, I just need the motivation to do it, and at the moment, I don't have that kind of motivation at all. But you never know. You never know. So I just need to drop a comment about my favorite radio station. Oh, okay, okay. I I wow. I don't. Well, yeah, I'm gonna have to think about that because I've got a couple of radio stations that I really, really like, and I don't know which one I like better.
What's your call sign, Todderbert?
On YouTube, he's Todderbert.
No, I'm asking Todderbert what's his call sign.
Oh yeah. What is your call sign, Todderbert? That might be sort of a wise decision. So yeah, very, very cool. Very cool. Well, yeah, it's as I said, that is definitely something that I could get into pretty easily and have quite a bit of fun.
Private.
What's that?
Well, I'm asking Todderbert, why do you want to keep it private?
I guess that's up to him. All right. Well, cool. Let's keep going with this guy. More objects in Pegasus. So NGC 7331, that great galaxy. Definitely take a look at that. Oh yeah, and I guess there was a supernova back in 1959 in NGC 7331. You can sort of see a before and sort of during. See, and we're pointing out this new star right there. So that's what a supernova looks like. I've been lucky enough to actually see a supernova with these eyeballs. Yeah, I saw supernova 1991T. T is in Tom, and actually made some photometric measurements of it, and published in the what is that? Oh, the International Astronomical Union circulars, which are now completely electronic, but at the time came out on these little uh, like sort of heavy index card paper, and then the observations, the reports um, were put on this, and those were sort of the latest and greatest observations. If you wanted that at the time was sort of the bleeding edge of at least astronomical observations. Um, they were posted up at the library, and yeah, they were updated. I think they were updated weekly. So yeah, I got to see 1991T through the 61-inch telescope up on Mount Bigelow, just north of Tucson. So that was extra special. That was one of those nights where it was clear, but the seeing was terrible, was really bad. So it was like a free night, right? Because I had a 61-inch telescope, a clear sky, and nothing to do. So yeah, of course, I would spend the entire night looking at things, looking at all my favorite objects, which were by then, sort of old friends, and so yeah, it was nice to see those things with a big scope, right? 1991T lasted, well, it lasted several months. What I would do is, before an observing run, this is when I was doing UBV photometry of white dwarf stars. And what I would do before an observing run is I would go to the library and I'd look at the circulars to see if there was anything, new and interesting, right? I mean, any new comets. I don't think they did asteroids. They did comets and supernovae and novae, timing of variable stars, just all kinds of little things. And so I would look through those and see if there was anything interesting, right? Because I'm going to have this telescope with a photometer on it. I could make some measurements, right? So 1991T suddenly appeared, and I don't remember how long after the discovery I looked at it. It was probably, several days at least afterwards. I'm not exactly sure. But yeah, at that time it was very, very red. Very red. So, all right. I don't know how I got off on that. Oh, yeah, supernovae. So there's also this cluster of galaxies that's called Stephan's Quintet. And there's actually 5 galaxies here. 1, 2, 3, 4, 5. And in order to see all 5 galaxies of Stephan's Quintet, you definitely need a very dark sky and at least a 16-inch telescope in order to see them all. This guy here, that guy right there, he is very faint, very hard to see. These, this guy's really bright. This guy's really bright. These two are pretty bright, but this guy is really hard. So this, in order to see this one, you need a 16-inch scope. No way around it. No way around it at all. Sorry about that. But it's very, very cool to see. Again, you know, it's not going to look like this because this is a long exposure photograph, right? So you know, our eyes don't work that way. So let's see. So they also show off a bunch of galaxies. So here's NGC 7814. It's a nice, cool-looking edge-on with a big bulge in the middle. And this dark lane. Look at that. That is so cool. And now, if you were to look at this through a telescope, let's see, we can go back to the listing and see how bright it is. 7814. So it's 12th magnitude. So yeah, in order to see this scope, you really need like at least a 10-inch, if not a 12-inch, 8-inch. It's going to be a little hard, a little bit hard. But if you've got, you know, a 12-inch or 14 or 16 or 20, you'd definitely be able to see that guy, and you'd definitely be able to see some hint of that dark lane, for sure. So here's NGC 7479, kind of a barred spiral guy. And then here's that that small cluster, NGC 7772, right? That one right there. Cool little cluster. And then here's a face-on spiral galaxy. What's that one? NGC 7217. So that's pretty much face-on, right? We're looking right, either right down on it or right up to it. So that's pretty nice. I wonder if HST has ever imaged NGC 7217. Let's find out, because it's sort of a pretty looking galaxy. So
Don't
let's
forget
see.
about doing a WISE thing too.
Yeah, WISE might have something interesting too. Doesn't have the resolution that HST has. So let's look at HST first. Now the chances are very, very slim, right? But we're going to look anyway. So these are all in the constellation of Pegasus, which we started looking at yesterday, and are probably going to continue for at least a little while here, because Pegasus is a huge constellation. Lots and lots of stuff within those boundaries. So I just like to, you know, this being a very casual, laid-back, fun live stream every single day, we could take our time and sort of go through things in sort of a casual, fun way, instead of trying to, you know, hurry through and rush things and everything else. Let's you know, just sort of go at our own pace here instead of trying to have to hurry and all of that. Let's just look. But anyway, very unlikely, but here we go. Oh, wow. Cool. Haven't been looked at in a while, but back in 2007. So towards the ultraviolet, 4556 is very violet. 3344 is ultraviolet. So let's take a look. Ooh. Wow. That is sweet. Look at the field of view here. That is sweet. Let's look at the other one. So this is shorter wavelength. Ooh. So noisier, but wow, look at this. Look at this ring. That's fabulous. That's fantastic. Okay, so yeah, then they increased the exposure time, or no, that's the same exposure time. Oh, here, they looked at it. Okay, nope, that's the same as that. But yeah, they did increase the exposure time here. So let's see. See, they went from 260 to 400 seconds. Let's look at the 400-second one. A few more photons in there. Wow, that's pretty nice. That's pretty nice. I'd like to reverse the the colors on there. We can do that with GIMP. Oh, is it done? I guess it's done. I just want to make black white and white black. Taking its time. Nice spiral galaxy, though. Holy moly. Here we go. Let's zoom. Let's make this a little bigger. And come on, you can do it. Invert. Here we go. That's beautiful. That's a nice one. Nice tight spiral. Yeah, pretty nice. Gotta say.
I haven't seen Crooked Ninja in a little while.
No, haven't seen that either.
I was talking about Crooked Ninja.
Crooked Ninja, yeah, haven't seen him or her. So there's some of the outer. I'm just doing a stretch on here, right? I'm just changing the brightness and the contrast to bring up the bottom a little bit. As you can see, right, it fills the whole field of view, even more so. Pretty spectacular. It looks like the center is still overexposed, though. So a little overexposed with this guy. The other one was less exposed, right? So yeah, I went from 260 to 400. So this one, same wavelength, different exposure. And I thought.
Now, when you use your GIMP, can you actually change the exposure time or no?
No. I mean, all that's just set, right? I mean, I'm just grabbing the JPEG images here, so I'm not even actually grabbing real data, right? These are just pictures of the pictures. So let's see. So that was one thing. NICMOS is an infrared camera. So they looked at this also in 2007, but at 1.9 microns and 1.87 microns. So NICMOS's field of view is much smaller. I don't know what to expect here. Oh, okay. Yeah. Pixels are bigger, much narrower field of view. Not quite sure why the center is knocked out like that. This isn't going to look much different. Yeah, a little bit more structure in there, maybe. With pick 2, 5997. Could be interesting. Okay, yeah. Nice. Just amazing. Amazing spiral detail here. Pretty incredible. Pretty nice. I'm going to save that one too. Let's see. Here's one from 1997. Okay, that's a Nick Moss again. Gonna look, yeah, about the same. And let's look at the earliest one from 1994 with pick 2.
When did the Hubble Space Telescope launched?
It was, we can look it up exactly, but I want to say around 1989, 1990, something like that. Let's,
I cannot believe it's still in commission today.
Yeah, well, it's going to come to an end pretty soon because, you know, they haven't been able to boost its orbit. So it's slowly coming down.
I know when's it going to be coming down?
Well, I think we have a lot of time, but it's going to start to become unstable. Yeah, so it was launched in Earth orbit in 1990. So 28 years. It's pretty good. Not bad. And it'll last another 5 years, maybe. I don't know. I think they use gyros to point and to steer and all of that. So, you know, as long as those are running, they should be good for a while. It's just, you know, the orbit is decaying, and after a while, it's not going to be usable. But yeah, I don't know how long that's going to take. Let's see if there's anything about that. Orbital decay and controlled reentry. So Hubble orbits the Earth in an extremely tenuous upper atmosphere, and over time its orbit decays due to drag. If it's not reboosted, it'll re-enter the Earth's atmosphere within some decades.
How do you boost the telescope?
Well, when the shuttle was operating and able to go to the HST, every single time it would go, almost every single time, it would give it a boost. So yeah, you need like rockets or something to keep it boosted. The space station...
What can boost the telescope now?
Nothing. Absolutely nothing, which is why, yeah, it's... So what it's saying here, right, is that it will re-enter the Earth's atmosphere sometime between 2028 and 2040. So within that 12-year period, if it isn't either reboosted or, you know, recovered in some way, then it will re-enter the Earth's atmosphere sometime between 28 and 40. So yeah, they have to reboost the space station as well, because I mean it's in a low Earth orbit and also suffers from drag. And I'm, you know, I'm not sure if they're using the spacecraft that dock to give them boosting, or if they have their own set of rockets. I'm not actually sure about that. But I do know that they have to give themselves boosts from time to time. And I'm sure, it's on some kind of schedule. So cheers to schedules and boosts. All right, well, cool. Let's that was a successful find. Let's so that's 7217. Let's go over to Wise.
In the ISS, if for quite some time, if it's yet to be boosted again, how again can it actually be abandoned?
Yeah, I think the timeline would be about the same and about as unsure. So it's usually going to take any object in orbit around the Earth in sort of a low Earth orbit. It's going to take anywhere from 5 to 30 years to deorbit and burn up. So when they stop deorbiting the space station, it'll slowly decay, and it might take 30 years though. Who knows? But I'm hoping that the space station continues. I mean, right now it's a national laboratory, which I think is nice. But I'm sort of leaning towards some kind of commercial entity, keeping it as a lab if possible, but also making it available maybe as some kind of platform, either for I don't know, tourists, or if scientists want to go up and just run their experiment, come back down, that kind of thing. But yeah, I think the tourist thing, I think that'd be kind of interesting. You spend a few days up there, and then you come back. Could be fun. Let's see. 7217. 7217. Let's take a look.
Now, I heard it's like amateur radio on the ISS, but the last time I was checking with the ISS, they were like the guy. I think the guy who was first behind it died recently, and it's been silent ever since.
Yeah. I hadn't heard any of that, but yeah, interesting. All right, so here we go. NGC 7217. So somewhere buried in there. Oh, there it is. So overexposed, which is sort of a bummer. Yeah, definitely overexposed. Well, but there apparently is the location of the galaxy. But yeah, very, very overexposed. Sort of as expected.
Yeah. All you gotta do for the amateur radio on the ISS, just search for ARISS.
Cool. Very cool. All right. Well, we're going to continue in Pegasus. Maybe not tomorrow. Tomorrow is the equinox.
And tomorrow I'm not going to be here.
Oh, Bobby, we're going to miss you on the equinox. Well, have a nice equinox. Everybody have a fantastic one. As I said, the equinox happens at 1:54. What did I say it was? It's not here. do this again. I don't remember where I put those things. Equinox. I like this one. Yeah, so 1:54 UTC tomorrow is the equinox. So that's 6 minutes before this live stream starts. So yay, we'll do an equinox show. Gonna miss you though, Bobby. So yeah, sorry you can't make it, but the equinox is gonna happen anyway. So all right, let's see, I'm gonna stop sharing, and I think it's time to get on out of here for now. So I'm gonna check my chat again really quick. Crooked Ninja, hey there. Oh, cool. Okay, I'll have to check out NGC 44858. So, yeah. Well, equinox is a special time of year. As I said, it's one of those experiences that every single thing on this planet experiences simultaneously. And I like those kinds of shared experiences, whether you know it or not, right? I mean, it's happening. And it's, how and why it happens isn't probably unique, but the sort of the details, the characteristics of it are unique to this planet. So yeah, we are having a singular experience, and it's very cool. So yeah, we'll do sort of an equinox live stream tomorrow, and just think about the equinox. And I've got a couple of stories I can tell, and yeah, I think that'll be fun. So all right, you guys, I am going to get out of here for now. So take care, and I will see you on the spin on the equinox in a little less than 23 hours. All right, take care, everybody. Bye.